Hello and welcome to 12.13, where we're going to be looking at the double angle identities. So it's going to be very similar to our last couple of sections. We're going to have a new identity, we're going to play with it, we're going to prove some stuff, and it's going to be fun. All right, here we go, double angle identities. So here's some more identities for you. And this is, if you can look at your theta and you can divide it in half, then you can do something like this. So this is going to be really helpful if you have sine of 120, I guess. You can divide that into 60, and then, you know the sine and cosine of whatever. So that's just one example. I don't even know if it's a good one. But you can divide out these double angles in different ways. So this one uses the Pythagorean identity, cosine squared minus sine squared. This one has another variation of that. And these are actually all kind of the same thing, just algebraed around. But it's helpful to have them all written out like this. And then, of course, tangent looks weird. Tangent always looks weird. He's an oddball. So let's see how they work, and let's do some problems. So looking at our first type of problem, it is find the trig values. So let's look at this. They give us a sine of theta, and they want us to find cosine of 2 theta, and then they tell us that what quadrant it is. And so if you remember, so here's 0 over here, here's pi over 2. So we're in this quadrant 1, which is really convenient because everything is positive in quadrant 1, so we don't really have to worry about negative signs and things like that. So let's look at what we've got and where we're going. So we need to find cosine of 2 theta. So I'm looking in this box because I just see a bunch of cosine of 2 thetas. We are given a sine of theta. So this one's got a cosine, so probably not that one. Cosine of 2 theta. Okay, this one has a sine squared. Well, we can just square our sine, so let's make that one work. So I'm going to write that down, and then we'll zoom in. So cosine of 2 theta equals 1 minus 2 sine squared of theta. So let's zoom in. Okay, we've got our equation, so let's plug in the stuff that we know. So, okay, we know 1 minus 2 sine of theta is 5 over 13, and then we're going to square that. So then we can simplify that, and this is kind of sort of calculator work. So we got 1 minus 2, 25 over 169. And then it looks like, okay, we put the 2 in, so then we've got 1 minus 50 over 169. And then when we combine all of that together, we get 119 over 169. Now remember, this whole blue part, that's kind of calculator work. So feel free to use your calculator in an intelligent way that you understand to get this right answer. All right, looking at number 2, it says if cosine of theta is a thing, and here is our range, find tangent of 2 theta. So let's talk about this real quick before we move on. So remember, we've got our coordinate plane like this. Pi is over here, and then 3 pi is over here. So we're in this quadrant right there. And if we were to draw a quick triangle in there, we're looking for tangent. So that's going to be opposite over adjacent. So what that means is, let's see here. This is a negative value here, and this is a negative value there. So that may come into play later on. And then our cosine is already negative, which that again makes sense because that is adjacent over hypotenuse, or adjacent over hypotenuse. So that's why this is negative. So I just want to bring that out before we start getting down this road, just to make sure that we don't get lost. Okay, so we are given cosine of theta. We need to find a 2 tangent. So I'm looking at my trig formula. And let's see here, double angle. So I was trying to be a little clever with this, trying to figure out if I had a formula that had tangent to theta and cosine of theta. I don't. So what we're going to have to do is we're going to have to make a triangle and figure out what else we have. So again, we've got our coordinate plane, and our angle that we're playing with is down here. It said, what did it say? It said cosine of theta is -7 over 25. So that means this is going to be 25. This is going to be -7. So now we need to use the Pythagorean theorem. And let's see here. So it's just going to be 25 squared minus 7 squared is 576, square root 576, and we get 24. So this is actually going to be -24, because if we look at it, it's going down on the coordinate plane. But we now have a triangle, so now we can actually talk about things like sine, cosine, and stuff like that. So that's going to help us out figuring out the rest of this. So now using that, let's see here, what am I going to do? Tangent of 2 theta is equal to 2 tangent of theta over, okay, yeah, so we are going to use that one. So that one says, okay, yeah, tangent of 2 theta equals 2 tangent of theta over 1 minus tangent squared of theta. So then we're just going to look at this guy for all of our tangents and things like that. So let's jump into that. So in blue, we're just going to put in the things that we know. 2 times tangent of theta is going to be opposite over adjacent. That's going to be -24 over -7. Those negatives will cancel out. Over 1 minus tangent of theta squared, which is again going to be -24 over -7, and we're going to square that. So then from here, we're just going to do some calculator work. Let's see here. 2 times 25 divided by 7. We're going to turn that into a fraction. So now we got 50 over 7 over, let's see here, 24 divided by 7. And then we're going to square that. And then we're going to take 1 minus our answer. And does that turn us into a fraction? So, yeah, we've got -527 over 49. And then let's see. So then we got 50 divided by 7. I'm going to multiply by the bottom reciprocal. So that's going to be times 49 divided by 527 equals a number, turn it into a fraction. We're going to get negative, because we do have a negative sign there, 350 over 527. Find the mistake. So 2 times 24 is not 50. So we're going to fix that. That's going to be 48. And then once we fix all of that and do the math correctly this time, we're going to get -336 over 527. Okay, just like we had double angle formulas, we also have half angle identities. So here we go. We've got sine of theta divided by 2 equals this whole mess. Same thing, cosine of theta divided by 2 equals this whole mess. Notice the plus or minus. That's interesting, that's new. And then tangent is this whole mess. Again, these are not things that I have memorized. I just look at the formula sheet. So if it kind of sounds like I'm breezing through these, it's because they're on the formula sheet. So using them is more important than having them memorized. So let's use some. So this is the same type of problem that we've been doing. Just in this case, we're going to use our half angle identities. So we are given a cosine, we are given a range, and then we are given a sine, or find sine of theta over 2. So first of all, let's start with our range. Let's see here. What is that? Pi over 2 to pi. So we're in this quadrant. That means things like cosine or tangent might be negative, which makes sense. Look, our cosine is negative. Our sine in this case, let's see here, that would be opposite over hypotenuse, would be positive. So those negative signs should cancel out. So that's good to know. Okay, so we're looking for sine of pi over 2, and we have theta over 2. So we're going to be using this guy right here. So here we go. Let's see, so that's fine. Okay, so sine of theta over 2 equals plus or minus square root of 1 minus cosine of theta over 2. So now in blue, we're going to just add what we know. So now it's going to be square root of 1 minus cosine of theta is negative 4 over 5 divided by 2. And then here's we jump into calculator work. So minus a negative. So that's convenient. I would hate to have a negative sign under a square root. That would be horrible. Okay, so using my calculator, I got 9 over 5 over 2, still under the square root. So we're going to multiply that 2 up. So when we multiply by the reciprocal, we're going to have square root plus or minus of 18 over 5. And then we're going to back up a little bit. Made a mistake here. Knew that sounded wrong. So this 2 is like 2 over 1. So when I multiply by the reciprocal, that's going to be 9 divided by 5 over 2. Okay, yeah, I just did that. So that would be like square root of 9 over 10. Plus or minus. So then from there, we've got plus or minus 3 over square root of 10. Can't have square root of 10 in the bottom, so we need to move that up to the top. So now we're going to have plus or minus 3 square root of 10 over 10. And unfortunately, our calculator kind of starts to break down when we have square roots. So, oh no, we're going to have to do math. Luckily, you're a smart individual. So I'm looking at number 5 here. We've got our range 0 to pi over 2. I love that quadrant because everything's positive, so I don't have to care about anything there. Find cosine of theta over 2. I'm looking at my formula. Cosine of theta over 2. I need a cosine, and this is a tangent. So that means that I am going to have to draw a picture and use the Pythagorean theorem to figure out the rest of my sines and cosines. So it says tangent of pi equals 2 square root of 6. And I could say that's over 1. Sure, why not? So that's going to be opposite 2 square root of 6 over adjacent. And I need the hypotenuse. So I'm going to do 2 square root of 6. Okay, I need parentheses. 2 square root of 6. Get out of the square root. Close parentheses squared. Plus 1 squared. 1 squared is just 1. Hey, look, we get 25. So then the square root of that is just going to be 5. Okay, from that, we can figure out our angle. Okay, so cosine of theta, goodness gracious, over 2 equals plus or minus square root of 1 plus cosine of theta over 2. So then we add the stuff in that we know. So now we've got plus or minus square root 1 plus cosine of theta is adjacent over hypotenuse. So that's going to be 1 over 5 and over 2. So then that's going to equal plus or minus, let's see here, 1 plus 1 over 5 is 6 over 5 divided by 2, which is going to be equal to 6 over 10 square root. And looks like we're going to have to do some square root math. So, okay. I don't think anything comes out of 6, but something's going to come out of 60, so whatever. So we got square root of 60 over 10 plus or minus. And then, let's see here. I don't know, a 4 comes out of 60. Actually, I don't need to write plus or minus anymore. Why don't I need to write minus? So that range does tell us that it is only going to be plus. So that's kind of why I can get away with that. Anyway, so I can pull a 4 out of 60. When I pull a 4 out of the square root, it's going to be 2 square root of 15 over 10. And that will be our answer. By the way, don't forget to simplify your fraction. Square root of 15 over 5. Okay, let's do some proving identities, and then I'll let you go. So looking at number 7, we've got a cosine squared, a sine squared, and a cosine of 2 theta. So this 2 theta is problematic because no matter what, I can't combine it with anything else. But we've got double angle identities. So let's switch that over. And which one do I want to use? So I need to get down to sine squared. I have a cosine 2 theta equals cosine squared minus sine squared and a minus sign. So that, I think, would get us where we need to go. I have a 1 minus 2 sine squared. Either one of those I think will get us where we need to go. But we are going to do my first initial reaction. Okay, so that means we're going to use cosine of 2 theta equals cosine squared minus sine squared. So this cosine squared stays. And we're going to change our cosine 2 theta into cosine squared of theta minus sine squared of theta using one of our double angle identities. So then from there, we'll go to blue. We're going to distribute our negative sign. And then combine like terms. When we combine like terms, oh dear. When we combine like terms, this cancels out with that one. And then all we have left is sine squared of theta equals sine squared of theta. So what's kind of interesting about that is actually not how the solution manual does it. So that just shows you that there are kind of multiple ways that you can go about proving these things. But again, this is your answer, not this. If you write down just this, that tells me nothing. You will not get any credit for this. I need to see the actual proof. So there you go. Okay, looking at number 9. So we've got tangent of theta equals this stuff. So generally, you take the more complicated side and you reduce it, and that's what I'm going to do. But just remember that tangent is equal to sine over cosine. So that's kind of my goal, is to get to that part. Okay, so then looking at these two things, we've got double angles. So I'm looking at my double angle identities. Cosine of 2 theta, there's a lot of options there. Sine of 2 theta, there's only one option, so that's at least what we're going to have to do. So I'm going to start on the bottom here. So this sine of 2 theta is also equal to 2 sine of theta cosine of theta. And then let's look at the top. We've got this 1. I can't really do anything with that. Minus cosine of 2 theta. So I'm looking at my double angle for cosines. I've got cosine squared minus sine squared. That 1 kind of messes stuff up with that one. I've got 1 minus 2 sine squared. That could work. The 1s would cancel out. Or cosine 2 theta of 2 cosine squared minus 1. The 1s would not cancel out. Okay, so we're going to go with the middle one. That's cosine 2 theta equals 1 minus 2 sine squared of theta. So we'll do this part in red. So cosine of 2 theta is equal to 1 minus 2 sine squared of theta. So now when we simplify all of that, let's move this over. So when we simplify all of that, we're going to distribute this negative sign to everything. And then our 1s cancel out. So now we have 2 sine squared of theta over 2 sine of theta cosine of theta. Now, here's the fun part. So our 2's cancel out. One of the sines cancel out. And now what do we have left over? We have sine of theta over cosine of theta, which equals tangent of theta. Isn't that beautiful? So we're going to try some of these out in class. It's going to be fun. We're going to prove some identities.